This conference will now be recorded.
Those attending online, is my audio fine now?
Yes, sir.
Yes, sir.
So first let's start with what all courses are starting today. Actually, as you are aware, VLSI domain majorly has two aspects. One is the VLSI majorly has front-end domain, one is the back-end domain. So the front-end domain is more focused on from specification to RTL coding and verification. As you are aware, VLSI domain has two aspects: front-end domain and back-end domain. Front-end domain is focused on all the steps starting from specification to RTL coding and verification. Back-end domain is from starting from the RTL code, whatever is verified till we chip is fabricated. These are the major. Each of them has lot of sub-activities. Let's say front-end domain has many sub-activities. Back-end domain also has many sub-activities. I mean, you can say these are all the activities in front-end domain. Starting from design requirements, architecture. Please just read through once because someone is telling my audio is a problem. I'll ask my admin to check. In the meantime, please read through this. So you see, so many domains, uh, with so many domains in front-end domain and back-end domain, we generally don't offer a demo session for everything separately. Rather, what we do is we offer a demo session for front-end domain where we cover most of these important aspects, all the things. We have another demo session tomorrow that is focused on the backend domain where we talk about these aspects. Then what we do is we have another separate sessions for individual topic. Let me explain now. I think you'll understand. So first course that we are starting today is RTL design and functional verification. When I say design and functional verification, it's all same course. Even when I say front end training for freshers, even when we say design and verification course, functional verification training for freshers, and ASIC verification, all these courses are same. Okay, that what does it mean? Whether I say design and verification, whether I say front end training for freshers, both are same. Other course that is starting today is the functional verification training for experienced engineers. So many times people who are working in the industry needs to upskill themselves. They won't be familiar with all the things. So for them also we have the course that is functional verification training for experienced people. And many times a lot of people who join our courses are also experienced people also. Then for those who are pursuing their BTech and MTech, they won't have the full time, right? Because they will have their own coursework. We give them flexibility to do individual courses. They can do a course on Verilog, they can do a course on system Verilog. Other than that, we are also starting course on FPGA design and verification, RTL design and integration course, okay. DFT design for testability. Okay, if you ask me, all these things are part of VLSI front-end domain, except for this one, DFT. Except for DFT, all these courses needs good programming expertise. And someone who want to get into the front-end domain needs a good expertise with the programming. Now, if you ask me, what about DFT? DFT doesn't need any programming expertise. DFT is one domain which happens in front end also, back end also. That's the reason I just placed it here. Otherwise, you can, even if you ignore, that's fine. Now, this demo session, what I'm doing, let's say it started at 9:40, we go till 1 o'clock. And after that, there will be a dedicated demo for DFT sometime today or tomorrow. In case some of you are interested in DFT, there will be a separate demo for DFT. There will be a separate demo for RTL design and integration, FPGA design and verification. So in summary, in case those who have joined for DFT, this is like this demo session. What I'm doing is like is the overview of the VLSI design flow and understanding of the front end. We will have another demo session for specific to DFT. What is DFT? What all projects are covered? What all, how the flow will be explained? Everything will be covered in that. Similarly, we'll have another demo for different demo for design and integration, different demo for FPGA design. This demo session, what I'm doing is till almost 12:30, 1 o'clock it will go. Our trainer, our admin will inform you the schedule for the DFT demo session. So any questions regarding these things? So before we understand what is VLSI, what is front-end domain, and what is back-end domain, let's understand where does VLSI come into the electronics system. Let's say if I take mobile phone, like what is VLSI in this? When I say VLSI, where is VLSI involved here? Can someone tell me where is VLSI involved in a mobile phone?
Processor.
Processor, okay. Chip, board, anything else? Basically, this mobile phone can be understood into 4 different parts. Can you tell me what all things makes up this mobile phone? Let's say mobile phone I'm able to use, I'm able to make calls, I'm able to use applications. What is that it has got? There are 4 things that are going into the mobile phone because of which I'm able to use it. Can you tell me what are those 4 things? 4 things that goes into mobile phone. Which are essential. What are those? First thing you need is what? Hardware, right? This physical hardware is required, right? Then you need something called as drivers, also called as firmware. Then you have OS. Then you have applications. Because these 4 things are there, we are able to use the mobile phone. The same thing applies for all other electronic products. Even if I take an example of a laptop, my laptop without an operating system, it's not useful. Imagine a laptop without having a hardware at all. Is it possible? No, right? So in summary, what I'm telling is everything in the laptop is essential, like the hardware. I think there is some noise from someone. Again, I want to check, is the audio good fine with everyone?
And with
Sure.
me.
Yes,
Thank
sir.
you for thank you for confirming. Okay.
Yes, sir.
Okay. So we were discussing that for any electronic system to work, all these four layers are important, starting from the hardware, the firmware, operating system, and the applications. This hardware, when it is developed at a large scale, it's called as VLS. So when you have only few transistors, you have a design with very few transistors, we call it as small scale integration or medium scale integration. When we are talking about Priya, please be in mute. Okay. So when we are talking about things like mobile phone and laptop, you need lot of complex circuitry. For that, you need large number of transistors. Can someone tell me how many transistors? Billions of transistors. So those kind of things is what we call as VLS. Okay. Now, what is drivers? These are the things that are developed on top of hardware. What is driver? I'll explain in some time. Then we have got operating system, and then on top of operating system, we have got applications. Okay. Let's, with this basic understanding, let's go through the presentation. If you look at a mobile phone, you see the only hardware. I mean, you visualize only hardware, but then there are things that we don't see. Okay, like hardware, it has got various chips, processors, screen, USB port, camera, sensors, audio, various things are there. But then there are things which we don't see. What are those like? We don't see the operating system, but we use it, but we cannot see it. Android, iOS. Then we have got firmware, different drivers. Then we have got different applications. Basically, all these things is what makes up the mobile. So, in summary, mobile phone has four layers. What are those? The hardware, like processors, camera, sensors, various things. Who develops hardware? The person who develops hardware is called as what? He's called as VLSI engineer. The person who is responsible for development of hardware is called as VLSI engineer. What is firmware? Different drivers, like we can call USB drivers, SSD drivers, PCI Express drivers. Now, what is driver? I'll explain in some time. Who develops firmware? It's an embedded system. So that's the difference. The person who develops hardware is called as VLSI engineer. The person who develops firmware is called as embedded system. Then we have got operating system like Android, iOS, Windows, Linux. Who develops OS? The person who develops OS is called as software engineer. Then you have got applications like apps in mobile, GPay, Maps, WhatsApp, everything, right? Who develops apps? The apps developers are even software engineers. All these four layers are essential for electronic device to work. Electronic system analogy. Let's take a simple analogy to understand an electronic system. You can think of a bus with passengers as an example. What all things are there in the bus with passengers? Bus is there. Can you have passengers without having a bus? No, right? Then what else you have? Bus is like a hardware. Driver, you have a bus driver, right? He's like our driver. he is called as firmware. What is the role of a driver, bus driver? He controls the bus. He controls how the bus will go. Will it stop? Will it go fast? Will it slow down? Will it take left turn, right turn? Anything he decides. Same way, our firmware controls the hardware. What is mean by that? When my mobile phone is going to switch off, I mean, is going to go into this power saving mode, when the volume will increase, all those things, when the brightness will increase, all those things my drivers will control, that is firmwares will control. Then you have a bus conductor. He's like an operating system. Okay, because he keeps going around the bus and he controls everything. I mean, he interacts with the driver, and he also interacts with the passengers. So he is the point of contact for everyone there. So then you have what? Passengers. Passengers are like application. Now there is no use of a electronic system without application. It's like bus without passengers, only driver and conductor. There is no use, right? So use case is, in this case, let's take a use case. A passenger wants bus to stop. Tell me what he will do. He will tell to the conductor. That means the application will inform the operating system that I want this bus. This is my requirement. Then what operating system will do? Will conductor go and apply brake? Will you go and apply brake? No, right? You will inform conductor. Conductor will inform driver. Then driver will control the bus. He has got various controls, so that he controls. Same thing exactly happens in the electronic system also. Whenever you invoke an application, the first information goes to operating system. Then it goes to drivers. Drivers will control the hardware. So you intimate the conductor, conductor informs the driver, driver will control the bus to stop. So this is the easiest way to understand electronic system. Now, going by this, for bus manufacturing, will the driver go and manufacture a bus? So that means to say, embedded system engineer is not responsible for manufacturing of hardware. Embedded system engineer is not responsible for manufacturing of hardware. So it is the VLSI engineer who is responsible. I mean, why I am explaining this is, sometimes those who have just passed out of the college can naturally have a confusion between what is VLSI, what is embedded system. So VLSI means what? It is about developing the hardware. Embedded system is about how to develop drivers which control this hardware. They don't have anything to do with the hardware development. They basically provide instructions to the hardware so that they control it. So what do they do? Let's understand. Like a bus driver wants bus to stop. What he will do? He'll apply the brake. He wants to take left. He will turn the steering to the left. So like that, he has got around 7-8 controls or 5-6 controls. The steering, handbrake, leg, accelerator, brake, clutch. So various things are there, right? Same way, an embedded system engineer generates instructions. Embedded system engineer generates the instructions which will write and read the registers present in my design. Understand, this is important. There are registers which are present in my design. Okay. Including. So the embedded system engineer develops drivers which involve writing and reading of above registers to control the hardware behavior. Let's take again one more analogy. I'm just giving analogy so that you get comfortable with the basics. Washing machine. Okay. You want washing machine to run for 1 hour mode, right? Different modes will be there, right? 15 minutes fast rinsing mode, then second wash and rinse mode. There are some different modes are there. Let's say it wants to run for 1 hour. Do you go and turn that cylinder in the washing machine? What do you do? You fix the mode. Then rest of the things are automatically taken care inside the washing machine itself. So here also same thing is happening actually. When you take a washing machine, you have a control knob. When you turn it or when you do select some mode, right? Either switch or something, you select a mode. You know what is actually happening? There is a microcontroller present in my washing machine, which goes and programs some registers. There will be some registers in the design which gets programmed for this value. Let's say 1 hour mode. It gets programmed, like I said, develops drivers, writing this register. Then accordingly, my washing machine understands that user wants to do this, so I will run in this mode. That is how it works. Same is the example. I hope you understood this. So when USB drive device is connected to laptop, for example, USB device gets detected. We start doing the transfers to USB device. So USB driver, so when we call USB driver, it is nothing but set of assembly language instructions. Whenever you call driver means like PCI Express driver, SSD driver, SATA driver, you will come across driver term. Who develops these drivers? Embedded system engineer. So finally, what those drivers will consist of? Assembly instructions. You know assembly language, right? Specific to each processor, you will develop instructions in that to control the USB related hardware behavior. Using those assembly instructions, the user will control the USB related behavior. Embedded system engineer develops these USB drivers, generally done using embedded C language. He develops using embedded C language, then through the compiler they are converted into assembly instructions. There will be a compiler which will take embedded C language and gets converted to assembly instructions. Okay. Embedded system engineer is not responsible for development of hardware. He is only responsible for development of drivers. You got the idea, right? What exactly we mean by drivers? What is essentially driver means? Drivers are developed using which language? Drivers are developed in C language, and this code is converted to assembly instructions. Then these are loaded into the memory. My processor starts executing these instructions. Next, let's take one more use case of driver. Let's say currently my mobile phone screen turn off time is 1 minute. Let's say if I don't use the mobile phone for 1 minute, what will happen? It will go into automatically screen will turn off. Why will it go into turn off? Tell me. Because to save the power. When it turns off after 1 minute, power is saved because it doesn't have to display. Okay. Now what is that I want to do is I want to change the time to sorry. Currently it is 30 seconds. I want to increase it to 60 seconds. Tell me what do you do? I give you my mobile. I tell you that right now it is 30. Change it to 60. What will you do? Will you open the hardware and go and change some number there? Tell me what do you do? You go to the settings. There you will say screen display turn off time. There you change 30 to 60. So at what level you are working? You are working at application level. So settings is a kind of an application. That instruction further goes to the operating system. That further generates some kind of instructions to the driver. Drivers will finally control my display in such a way that they will turn off after 60 seconds. We want to change it to 60 seconds. How do we do it? Do we open mobile and apply number 60? No, we don't do, right? You are an application. Basically, whatever you are doing is that you are an application. You shouldn't directly interface with hardware. So how do we do? Open the settings, change 30 to 60. That this instruction goes to OS. OS conveys this to power management related driver, because the switching on and switching off is related to power management. This driver consists of instructions for processor writing to a register in the design to change the number 30 to 60. You understand? Processor writing to a register, what that write will do? Change number 30 to 60. This is how this change happens. So anything embedded system engineer does, he will work with the registers in the design. Why is it important to know this information? Like you may say, we are only here for VLSI demo session. Why is it important for me to know? It is important because you need to know, for a person, let's simple example, the person who is manufacturing hardware or a bus, let's take an example of a bus. Is it okay if he keeps steering in the back and accelerator in the front of the bus? No, right? You understand what I'm telling? Like I'm telling a scenario where everything is generally present here only. A, B, C, accelerator, brake, clutch, and even the handbrake, everything is gear, everything is present here only. I develop a bus vehicle where steering is present here, gear is present here, accelerator is present here. Will it work? No, right? Means I need to develop my hardware in such a way that it is comfortable for other people to use it. The driver, most importantly, driver should be able to, bus driver should be, it should be comfortable for him. So as a VLSI engineer, I need to know how embedded system engineer uses my hardware so that it is comfortable for him. He should be able to control my hardware easily. I should not make it very complicated for him. That is why I need to know, I need to have some understanding of embedded systems also, little bit, not in depth. That is what. As a VLSI engineer, you need to understand how the hardware works. A very good understanding is required. In-depth understanding of hardware operations is required. Because if I am manufacturing a bus, I need to know how bus works, right? Everything. Okay. How firmware interfaces with hardware. I should know how bus driver is going to use the bus. I should understand. Then only I can develop a bus which is good. A decent understanding of how firmware works with the hardware. I don't need to worry. Bus manufacturing person don't need to know how the passenger will come. He doesn't worry too much. His only concern is immediately with the driver. So I, as a VLSI engineer, I don't worry about applications much. Okay. I don't worry about operating system. I only worry about my hardware and embedded system, drivers, these are the things. That is the reason we are going through a basic understanding of this. Okay, so with this, we understood what all things makes up an electronic system. Tell me, what are the 4 layers? Hardware, firmware, operating system, and applications. Then we have understood how all these layers interface with each of an embedded system. There are 2 different roles. Okay, one is about developing of hardware, one is about how to access the hardware and control the hardware. Now, since our demo session is on VLSI, let us go into little deep into VLSI design. Finally, our goal of this demo session, if you ask me at the end of demo session what I should have understood, if you ask me as a student, should have got an idea of what is VLSI flow. Where does it start? It starts from requirements. Where does it end? when you do the packaging of the electronic product. Like your mobile phone that is there in your hand is the packaged one. So what all steps are required? In that, what we mean by front end domain, what we mean by back end domain. Then to get into front end domain, what skill set you require. To get into back end domain, what skill set you require. Okay. So these all things we are going to understand. And finally, we will go a little deep into the front end domain. What is functional verification domain? What is the schedule? All those things we will understand. Okay. So before I proceed, any questions you have so far? Now let us get into VLSI design styles. What is VLSI is about? Manufacturing of the hardware, right? So VLSI stands for what? Very large scale integration. When you say very large scale, means in a bulk, in a large amount we are integrating. What are you integrating? Tell me, what are we integrating? We are integrating transistors. Since we are integrating billions of transistors, it is called very large scale. It's called very large scale since we are integrating billions of transistors. Now, VLSI styles. In VLSI, there are two major styles in developing of VLSI chips. One is called as ASIC, one is called as FPGA. If I want to develop a mobile phone, there are two ways in which the mobile phone can be manufactured. One is ASIC style, one is FPGA style. ASIC stands for application specific integrated circuit. Example, see what is mean by application specific is you're developing an integrated circuit, a hardware specific to an application. Means what does it mean? You want to use mobile phone. Can I use mobile phone as something else? No, right? I cannot use it as a laptop. The company who has developed this mobile phone, their only intention was to use it as a mobile phone only, nothing else. That is why it's called as application specific integrated circuit. Hardware is developed for a specific application. Example, mobile phone chip. Even laptop I cannot use it to make a phone calls. So everything has a specific requirements. Second style of development is what? FPGA. What does FPGA stand for? Field Programmable Gate Array. In this case, what happens is same FPGA board can be programmed to behave like different applications. Means different devices. It can be programmed to behave like a mobile phone. Same board can be programmed to behave like a laptop chip also. And same thing can be programmed to behave like, if this is assume this is FPGA chip, FPGA board, I can configure it to behave like a mobile phone. I can configure it to behave like a laptop chip. That kind of things are called as field programmable gate array. Tell me which one looks better? Initially speaking, FPGA looks better, right? Because I can use the same thing for different applications. But as we go forward, we will understand that ASIC is preferred. Industry prefers ASIC compared to FPGA. How much preference? 85% of the work in the industry happens in ASIC. FPGA only 15, roughly. Okay, there is nothing like exact 15, plus or minus something. 85 plus or minus something. Now, what is the advantage? See, initially it looked this one to be better, right? Going by what we understood, since FPGA board can be used flexibly for different requirements, it was actually better. But then why industry prefers ASIC? The only reason is cost. Only advantage is cost. There are some other advantages, but major advantage is the cost factor. How much cost difference will be there? Roughly, to give you a rough estimate, let's say if chip here costs $50. Here it may only cost $15. So it's a big difference, right? It's like how much difference, I'll tell you in a simple terms that we understand. Same mobile phone is available for 50,000. A mobile phone with same features is available for 15,000. Which one will you buy? Say 15,000, right? Same is the reason. Industry also, though it may have some advantages, small advantages, but you will still go for this because there is a huge difference in the cost. That is the advantage ASIC offers. The way ASIC works, the flow works, it becomes cheaper automatically. In simple analogy, in a very simple analogy, it's like very simple, something off the topic. Okay, making sweets, for example. If they have to make each sweet separately, okay, it will cost more amount. If I make a sweet in a plate, just pour all the liquid and then cut the pieces. Which one will be cheaper to manufacture? I mean, to make the sweets? Bulk, this approach, right? Rather than making individual sweets, one manually making. Something similar is ASIC. Now, how it works, we'll discuss as we go. Any questions so far? Though it looks like FPGA approach is better, industry prefers ASIC flow due to low cost of manufacturing. If ASIC is cheaper option, why we don't do everything in ASIC then? Again, the question comes, if ASIC is cheaper option, why don't we do everything in ASIC only? Okay. We'll discuss that also. Till some level, FPGA is actually better. What is the difference? Let's understand. So the problem for ASIC is initial investment is high. What is initial investment in case of sweet making? You have to purchase that plate, you have to come up with that process, you have to melt it, and you have to pour the liquid. So there is a process. I mean, you may ask, it's nothing, right? I'm just giving an analogy. Rather making individual things, you make it manually. So there is no other investment required. So here you need a process that does everything. So for ASIC, initial investment is very high. Because of that, only if you need bulk production. Bulk means what? Lakhs of chips you want to manufacture. You go with ASIC. Small production, small quantity, you go with FPGA. So now let's understand the cost of ASIC design flow. It will cost multi-million dollars initially, since we need to start everything from scratch. Once the flow is working, per chip cost is less. Once the flow is set up, everything is working fine, manufacturing each chip will be cheaper. About cost of FPGA design flow, lakhs of dollars or less. I mean, it won't cost so much, it will cost less. Why? Hardware is readily available. Hardware is readily available. But per chip cost will be more. What is the compromise? In ASIC, initial investment is high, but later per chip cost will be less. In FPGA, initial investment is less, but per chip cost is more. So how does that look in waveform is? ASIC FPGA starts with a low investment cost. See, your cost is low here. This is cost axis. This is the number of units, volume. When you start, your initial investment in FPGA is less. ASIC, it is very high. But you see, as you manufacture more chips, FPGA is this kind of curve. Very slant is there. This is less slant. So this is the cutoff point. That's the cutoff point where FPGA becomes costly and ASIC becomes cheaper. So the point is what? If I want to, let's say this number is 10,000, for example. This number will be what? 5,000. This is 15,000. Let's say I want to manufacture 5,000 chips only. I know that this whatever chip I'm developing, it will only require 5,000 chips. In this case, which option is better? FPGA. Why? How do I say? I draw a line like this. I draw a line like this. I see that FPGA is lower compared to this one. So that is the reason for anything in this range, 0 to that 10,000 number, I go with FPGA. Anything more than 10,000, I go with ASIC, because after that stage ASIC becomes cheaper. This is how companies make decision. This is how companies make decision. Let's say you want to manufacture mobile phone. How many chips are required for mobile phone roughly across the world? Millions, right? Millions of these phones will sell. Not only in India, every place they will sell, right? Uh, though sometimes packaging is different, but same chip goes into many mobile phones actually. Okay, in that case, will I go with ASIC or FPGA? ASIC. That means, let's say Qualcomm is working on this chip. They will use ASIC flow to manufacture this chip, not the FPGA. Another example is, if I take a aeroplane requires some electronics, right? A lot of electronic system is required. How many aeroplanes do we manufacture in a year? Maybe hundreds or maybe thousands, right? Does it go for bulk production? No, right? It's only in hundreds or thousands. Now, will they prefer FPGA or ASIC? FPGA. That means if there is a company like Airbus, they will prefer FPGA technology in their companies, because that is where you hear any aeronautical companies, Airbus, Boeing, all those kind of companies, they will only use FPGA. If you join those companies also, they will only look for FPGA expertise. Okay. Whereas if you join as Qualcomm, Intel, Broadcom, their products are all bulk manufacturing products. Okay. Nvidia, what do they do? They develop graphics processors, accelerators, all those things, right? Are they used in limited or bulk? Bulk, right? They, every lot of applications can have graphics processing. They'll use ASIC. So that's the point. ASIC versus FPGA. Any VLSI chip can be developed in either ASIC or FPGA flow. Decision is based on overall cost. I gave you a simple example like ASIC based flow may cost $15, 50. Don't think that always. It's not like 15 and 50 is not a rule. I'm just giving an analogy. Okay. Which company go for ASIC based production? Companies which manufacture products for bulk uses, like mobile phone sells in millions. Which company go for FPGA based production? Companies which manufacture for limited applications. Hardware used in flight sells in thousands only. So what are the advantages of ASIC or FPGA? Tell me. What is the advantage of ASIC or FPGA? Please read this once. Okay. So ASIC advantages are what? It is cheaper, consumes less die area, hence it is cheaper. Why is it cheaper? One of the reason is it is customized to be small, so it is cheaper. Next, provide flexibility to customize the design features. You can customize because you are manufacturing specific to your requirement. You can customize, and it is power efficient. It can work at higher frequencies compared to FPGA. So these are all the advantages of ASIC over FPGA. So it is not only the cost, it is small in area, it can be customized for my requirements. Now let us understand distinct advantages of the FPGA or ASIC. What is the first advantage? If chip has a bug, the very important advantage is if chip has a bug which is detected after manufacturing, we don't incur bigger cost. The cost won't be too high. Whereas in ASIC, everything is wasted. We don't have to implement the entire flow again. Bug can be fixed in the next FPGA board. We don't need to start from scratch. There's no need to start from the scratch. In ASIC, if there is a bug, we need to do entire flow again. FPGA is quick because you have the board readily available. It is quick. You can finish the flow in less time. Since we don't need to start from scratch, board is readily available. Amount of time taken to is relatively less compared to ASIC. In fact, FPGA is also used at one stage of ASIC flow. Even in ASIC flow, FPGA is used to check that whatever I have developed, let's say I have done Verilog coding, verification, I want to confirm whether it is working fine or not. Because instead of manufacturing using ASIC, first I will do what? I'll do something called as FPGA prototyping. FPGA prototyping is used to check ASIC behavior before it is manufactured. It's like, in a simple terms, I was giving you sweets example, right? First, what I will do, I want to prepare a sweet. Okay. Instead of going for a process where I develop the machinery, everything to bulk manufacture the sweet, what I will do is I'll follow my simple steps called as FPGA prototyping. I will make it on FPGA, how the sweet will look like, and I will taste it. Everything is fine. Only once I know that this is fine, then I go for this step. So first we prove our idea using a FPGA board. Our design is working fine, no issues, everything is fine. Then we go for ASIC production. Understood? That process is called as FPGA prototyping. What is FPGA prototyping? Implement the logic on FPGA board and check the behavior. Have you got the idea about what is ASIC, what is FPGA, all that? Does all companies work in ASIC only? Does all work in FPGA? No. Specific to their requirements. ASIC versus FPGA. If you take an example of aeroplane, they are not really concerned about the cost. They are not really concerned, not the cost per chip. They don't worry about cost per chip first. They don't worry about the area because aeroplane is already so big. Instead of keeping it this much, you increase another 1 centimeter, nothing is going to happen. Okay. In those cases, for them FPGA is always good, right? Because they don't have to go through the whole ASIC flow, which will cost them millions of dollars. I have just given the same example. So, I mean, what I was explaining is, if you want to go for bulk production, you go with ASIC. If you want to go with limited number of production, you go with FPGA. VLSI design flow, how it differs for ASIC and FPGA. Let's now understand how VLSI design flow differs for ASIC and FPGA. VLSI front-end domain flow is similar for both ASIC and FPGA. In both the cases, user need to understand the design specification. See, front-end domain flow is similar. Whether you become a FPGA engineer or ASIC engineer, what you do in the front-end domain is similar. Because in both the cases, you have to understand what is the electronic product you want to develop. Specification will be same. You develop the RTL code using same language, Verilog language. You have to verify it. So where do they really differ is in the backend flow. The way things happen in the backend domain is where they differ. Okay, in both the cases, user need to understand the design specification. Implement the design using Verilog or VHDL. The functional verification of design behavior using SV and UVM. You still need to do functional verification. Then where do they differ? Where do they differ, ASIC and FPGA? Majorly, they differ in VLSI backend flow. They differ in backend domain flow. I mean the way the physical design is done, the way DFT is done, the way timing analysis is done, little different. The flow starting from physical design to custom layout is where they differ. The way we do floor plan, power plan, placement, CTS, routing, IR drop analysis is where they differ. All these steps differ. Now let's understand ASIC design. Okay. So with this we complete the second part of our lecture. What is that we have understood so far? VLSI design flow can be done in majorly two styles. What are the two styles? ASIC and FPGA. Okay. We understood where do we prefer ASIC style of flow, where do we implement FPGA style. Then we understood ASIC advantages over FPGA. What are the advantages of ASIC over power efficient, and it is customized for my requirement. Okay. And then what else? Cheaper, smaller, I mean area will be smaller. Okay. Customized and power efficient also. Because you are customizing, you can make it power efficient also. Now let us move on to the third part of our lecture, that is ASIC design flow. We'll be mostly focusing on ASIC. Now why we talked about FPGA is to tell you that there is one more domain in the VLSI called as FPGA. Lot of training that you see in our institute, many places, is focused on ASIC. Wherever, I don't want to name the institute, take any institute, their flow will be only on ASIC. Very few people teach FPGA. So I wanted to tell you that there are opportunities in FPGA also. You can even undergo training, even we offer FPGA training. You can even undergo training on FPGA. You will have opportunities in FPGA also. Because some companies, it's a requirement for them to use FPGA only. They cannot use ASIC. Because if they use ASIC, they'll have to spend a lot of money. So hence, I wanted to tell you that there are opportunities in both ASIC and FPGA. So you can sensibly decide which one is suitable for you. We'll discuss more about that in this session. Now let us focus on ASIC design flow. What is involved in ASIC design flow? Let's take one simple analogy to understand ASIC design. You can think of ASIC design flow similar to house construction. I mean, what all things happen in house construction? It starts from requirements. What is requirement? What kind of house do we want? Number of floors, number of houses, number of rooms, everything, right? Then whom do you go after that? Architect, right? You go to a house architect. You tell him what is that you will give him? You give your requirements. This is the kind of house I want. Okay. Because let's say if I want to construct a house, I don't directly go to architect. I'll first sit and understand what do I need. That is requirements. Once I have requirements, then I go to architect. Okay. What are the inputs to him? Requirements are the inputs. What does he give me as an output? Various plans, architecture plan, okay, plinth, electric, various things he will give me. Then whom do you go to? You go to a contractor or a masonry. Okay. You give whatever is the output of previous stage, it is input to the next stage. Then what he will do? building structure. He will construct the building and give you. Is everything done there? No. Then you go to various people, plumber, electrician, carpenter, painter, various people. Finally, by the time you get everything done through, your house is ready. VLSI design flow is also like that. It's not any different. It is also similar. You see, there are so many people involved, right? Even in VLSI, it's not like one person does entire chip. There are many people doing different activities in a coordinated manner is what makes the VLSI flow. Similar to this house construction flow, our VLSI flow, ASIC flow, consists of around 15 steps divided into two major categories. Even in house construction, we can divide it into two major categories. One is you constructing the basic structure, slabs and everything. Okay, walls, slabs, everything. That is one step. Second is remaining thing, everything else like plumbing, electrician work, carpentry work, everything, paint, everything. So that's second. So like that, we can divide ASIC design flow into two major steps. One is front end domain, one is back end domain. Front end domain starts with requirements. It goes to the architecture, RTL design, RTL integration, and RTL verification. Then finally, DFT at the RTL level. So these all steps are done as part of the front end domain. Then we have got back end domain, which starts with synthesis, where in synthesis, what do? We convert RTL code to gate level. After synthesis, what do? DFT at the gate level. See, DFT is involved front end and back end also. Once we do when it is in RTL level, second when you do it when it is in the gate level format. Then after DFT we have physical design. Then after physical design we do static timing analysis. Then we do custom layout, physical verification, then GDS2 extraction. What is GDS2? Is graphic design system. That stands for graphic design system. What is it's in a simple terms? Graphic design system will tell if this is my silicon, this is my chip. Chip is what? Silicon, right? Where the doping should be done, p doping should be done, where n doping should be done, how much doping should be done, where the metal should be deposited, where the oxide should be deposited, how much depth it should be done, where the etching should be done. That all information will be present in this manner. What is that graphic design system will have? It will have information about the 3D information. Okay, you understood, right? Once you have this file is sent for fabrication. After fabrication, you check whether each chip is working fine or not. Once you have done the fabrication, you check whether each chip is working fine. That is called as post silicon validation. What is post silicon validation? We check whether each chip is functioning properly. Once it is done, then you go for packaging. Packaging means what? Finally making an electronic product like this. That is where you get this. That means the mobile phone which you are using went through all this process before you start using it. This work, let's say you purchased it in 2023. Work on this would have started somewhere in 2021, 2 years ahead. Then it took almost 2 years by the time you're using it. Okay. I hope you understood what is ASIC design flow. Let's understand front-end domain flow. We'll understand this and go for a break. Okay. VLSI front-end domain is similar to software flow. See, I'm purposefully not talking about all these things. What is DFT? What is physical design? Because as of now, let's not get into it. In case you are interested in backend domain, tomorrow there is a demo session. There you will understand everything in depth. We'll only focus more on this one for today. VLSI front-end domain flow is similar to software flow. Like software engineer, what is the skill set he requires? Tell me. He needs to be good with programming languages like C, C++, and Java. Should be good at reading software specification. I mean, given a software specification, you should understand what is the software requirement, what algorithms I need to use. Develop algorithm and implement the same using C, C++, or Java or similar languages. Basically, he should be able to use C, C++, or Java to implement the algorithms. Should have good programming skills, right? I mean, someone who want to get into software job should be good with programming skill set. Same is the scenario for VLSI front-end domain engineer with some differences. What are the differences? Should be good with programming or have inclination towards programming. You should have some inclination. Let's say you don't need to be expert. Why you can't be expert? Because let's say many of you are from electronics. You don't do any C++, Java in your coursework, right? Mostly you do C in say, first year. And after that, you don't do much. But you should have that interest that, okay, I can learn. That inclination you should have to get into front-end. Let's say you don't like at all. Whenever you didn't understood, you don't like at all. Then front-end domain is not the right domain for you. Okay, you can't even go to embedded systems because embedded system also needs good programming expertise. Like we learn C, C++, Java. In here, we need to learn Verilog, SV, UVM. Like the way in software, the person should be good at reading software specifications. You should be good at reading hardware design specification and understand the design functionality. Implement requirements using various protocols. Like here we use algorithms. Similar to algorithms, people should be good with protocols like DDR protocol, SPI protocol, AMBA protocol, various protocols like USB, PCI Express, DDR, AMBA, SPI, various protocols. They should be comfortable. So in summary, both of them requires good programming skills, familiarity with the languages, reading the specifications, this kind of expertise. Now, the second question comes, where does the VLSI differ from software? Front-end domain is where they are similar, but where do they differ? It's a back-end domain. What is the difference is, software don't have anything called as back-end domain. In software, you don't manufacture a software. Once you develop a software, you use that software directly. Let's say I want to use Windows Office. Do I get it as a chip? I get it as an application I install in my laptop. Whereas in electronics, you don't buy a code. Let's say you go to some shop to buy a mobile phone. They don't sell the code. They sell the electronic product. So that is the difference between VLSI and software. In software, there is no backend domain. Software doesn't require backend flow. Backend flow means what? Process of converting Verilog code into chip. In software, the code is installed and used. No need to manufacture as a chip. You don't manufacture it as a chip. In VLSI, the functional verification plays a very important role. If there is a bug in the chip, which is detected once it is in production, the bug can't be fixed. Let's say I'm using a mobile phone, there is a bug in this, there is a problem in this mobile. I cannot do anything, I have to throw it off. But in software, you can go and update the application and make it work. See, in VLSI, there is no concept called as patch. In software, if there is a bug, it can be fixed easily and can be released as a new version of the software, what they call as a patch. In hardware, there is no patch. So hence, verification plays very important role in VLS. Means in actually in software domain, testing engineers don't have much important. I mean, I wouldn't say not important at all. The developers have a lot of importance compared to test engineers. Whereas in VLSI, functional verification is as important as design engineering. Because even if you miss one bug, the whole chip won't work. Small bug also, small feature is not work. You have to do everything again. In software, you don't need to do, because in software you update the bug and release a new version of the software. In summary, these are the steps in the pre-synthesis flow. These are the steps in the post-synthesis flow, starting from synthesis, GLS, BFT, physical design, static timing analysis, custom layout, till we do post-silicon validation. Okay, so let's now take a break. Let's meet in 10 minutes. That is 11:05. Let's meet. Once we meet, we'll continue with the further things. We'll try to understand different job roles, what is the skill set required, everything.
This conference will now be recorded.
So before the break, we were discussing about ASIC design flow. We understood that ASIC design flow is majorly two steps. One is front end domain and back end domain. And we also discussed that front end domain flow is similar to what is done in the software domain. Just that languages are different. Instead of learning algorithms in software, you should be good with algorithms. Let's say people in software domain, when they want to get into Amazon or Google, right, they learn algorithms, advanced algorithms, how to implement algorithms. That is what they do. In VLSI, they learn protocols. Some people who want to switch to better jobs, let's say Qualcomm, Intel, they learn PCI protocol, DDR protocol, USB protocol. So that's the thing. Okay, and both require programming expertise. You should be good with the programming skills. Then where do they differ? Backend. In software, there is no backend domain. Okay. Whatever we call as testing, manual testing, test automation in software, it is called as functional verification in VLSI. That is the course most of you are looking for now. It's similar to what software test engineer does in software. You are going to do in VLSI, but a little different. You hold a lot more importance here compared to testing in software. Now let us understand different job roles in the VLSI domain. In front-end domain, the person who works on the team which works on design requirements is called as marketing team. The person who works on architecture is called as design architect. The person who works on RTL coding is called as RTL design engineer. The person who works on RTL integration is called as RTL integration engineer. Functional verification called as functional verification engineer. DFT at RTL level, DFT engineer. Synthesis engineer. Formal verification engineer. Who does DFT? Again, DFT engineer. Physical design engineer. HTA engineer, layout engineer, physical verification engineer. In summary, so many people are involved in manufacturing of a chip. So many people are involved. Few people work in front end domain, few people work in back end. Generally, what is the team distribution is? I mean, first of all, what you have to do is you have to decide whether you want to get into front end domain or back end domain. How do you decide that? If you have some interest in programming, you are already good with Verilog, okay, then you go for front end domain. Otherwise, if you don't like programming or you are passionate about back end domain, then you go for back end. Let's understand ASIC team distribution. What I want to show here is that there are opportunities everywhere. You should not think that only front end domain has jobs, only back end domain has jobs, nothing like that. If let's say if a house construction happens, does everyone gets work or only one person will have work? Everyone has work, right? Same thing here. When a chip is manufactured, every type of engineer is required. All categories of engineers are required. But sometimes demand may increase, demand may decrease a little bit, but otherwise there will be requirement for everyone. So let's understand the typical ASIC team distribution. Let's say you go to Qualcomm or any company. Let's say there are 50 people in the project. Let's say there is a company which is working on mobile SoC. Let's say the team size is 50. So around 25 to 30 will be working in front end domain. Out of them, how many architects will be there? Only one. You need only one architect, right? For my house construction, there are almost 40 people worked. There's only one architect for entire house construction. Design team will be less, 4 to 6, around 4 to 6 people. Verification will be. So who needs more? Where do you need more people? Front end functional verification, you need more people. In front end, you need more people in functional verification, which is almost 30 to 40% of people. Then you have back end, where the remaining people will work. Okay. Even in the DFT requires around 2 to 5. Physical design requires around 10 to 15 people. Layout, static timing analysis 3 to 5. Layout 3 to 5. So where do you need more people in back end domain? Physical. So that is where you see a lot of opportunities in these two domains. In the job, when you look for jobs, you'll see a lot of opportunities in functional verification domain, lot of opportunities in physical design domain. Okay. Does it mean that there is no opportunity in DFT? There is no opportunity in design? There are opportunities, just that number varies. The number of people required will vary. Okay. And accordingly, what happens is, lot of people join this training. Lot of people join this training. Number of people who join DFT training will be less. So automatically it gets adjusted. In summary, in our institute, there could be 200 people joining functional verification domain, assume. I will only have 40 people joining into DFT. So naturally it's adjusted, right? For the number of jobs, it gets adjusted. But still my point is, if you still say I want to make a decision based on where do I have a better chance of getting a job, general observation is that this is kind of evergreen domain, functional verification, where you will find opportunities anytime. If you are good with the subject, you will definitely find an opportunity. So if you are particular about, I want to be 100% getting a job, at least I need 100% opportunities, you can go for functional verification. Okay. But as I said, you should be good with you should have inclination to learn programming. Second is of course there will be a competition, bit of competition, because a lot of institute training, lot of students, you should be ready for that. So have you understood what is a typical ASIC team distribution? Any questions so far on this? Now let's go to the training schedule. Okay. Before we go to this, let's understand the term what is functional verification, what is DFT a little bit, because that is what we are talking about, right? Functional verification is about, I have developed a I want to manufacture a mobile phone chip. Let's take a simple example. Instead of mobile phone, let's take a simple example. Mobile phone. First, I started with requirements. After requirements, whom I went to? Architect. He gives me specifications and architecture. Then there is a team called as RTL design team. They use Verilog language to develop the code. See, what do they do? I'll show you. They develop these kind of files, okay, which are developed in V file, means Verilog file. If I take one of the example, let's say they develop this kind of code, which is done using Verilog language. This is a Verilog language basically. Always at something, if this condition is true, then if this condition is true, do this, else do this kind of thing, else do this. So they will develop this kind of code. So two things are required here. First of all, you need to know Verilog language. Second, you need to know what is this, why you need this kind of code, why you need this if condition, why, what is this logic, you need to know, right? Only then you will be able to develop it. So the person who works into RTL design should be good with Verilog language, should know this algorithm, I mean, how this flow is happening, what is this signal, what is this signal, how to develop, because he is the one who is developing this code. Understood, right? Then what is the role of a RTL integration engineer? All these files are individual blocks, right? Integration engineer puts together everything, makes a big block. A person who does integration puts all the things to make a one big block, that is called as RTL integration. Then what is functional verification engineer? RTL verification engineer, he verifies whether whatever we are seeing here, has it been done properly. Let's say if I look at this code, there may be some mistake here, for example, some mistake in this logic. Okay. I'll tell you one simple thing. Let's say I remove this. What is this called as? Bitwise not. If I remove this, will it work? It won't work. If I give you this code after 1 hour, will you be able to detect where the problem is? Let's say if I go and come back. Now tell me, where is the problem? If you go through the code, somewhere in this code there is a problem. Tell me which line number is the problem. You don't even know. We know because we gave line number 314. But otherwise we don't know what is the problem also. Right? So looking at the code, we cannot tell where is the problem in the design. What is the problem if I leave it without checking it? Output won't come properly. It will get manufactured into a chip. That chip won't work properly because this condition is wrong. There will be some scenario in my mobile phone where it won't work properly. Okay. Many times it may work, but sometimes it won't work. Is it fine? No, right? It should work fine always. So the role of a verification engineer is to catch these kind of bugs. Means he will finally tell that there is a bug here because it should have been inverted condition. How he will detect? He won't scan through each line. He won't go through each line and tell whether it's correct or not. He will take the design, he develops something like test bench. Through the test bench, he applies the inputs. He also develops his own model called as reference model. His own model called as what? Reference model. Same inputs he will apply here. He is expecting some output. He checks whether this output is matching or not. Based on that, he will tell, yes, this is good. This is wrong. Then if it is wrong, let's say this is mismatching, for example. Let's say there is a mismatch happens. Then he will trace where is the problem, which block is the problem, which direction. Then he will pinpoint that, oh, somewhere here there is a mistake. That is, this line has a mistake. Let me again repeat. What is the role of a verification engineer? To detect errors in the design. Who has developed the design? Design engineer, RTL design engineer has developed. Now the bug can be anywhere. See, if I remove this line, by mistake he has done. The person who has developed this code, unintentionally he didn't develop that line, that word he didn't keep. Looking at this code, can I tell that that is a problem? So for that, what my verification engineer does is, he has a design. This is design is provided by whom? Design team. He develops his own model called as reference model. Then he applies some inputs. The same inputs he applies here also. He applies inputs to both design and reference model. Based on what output comes here and here, he compares them. If both are matching for every scenario, then it's fine. Design is working fine. If it not matches, he scans the design. Where is the problem? Where is the problem? Where is the problem? I mean, it's not like randomly going. He will find where the wrong thing is coming from. Where is that wrong thing is coming from? Finally, he will reach a point where he will detect that this design, this code has a problem. Then he will inform it to the design person. He will update this code and again release it. So this is the role of a verification. So a verification engineer skill set is not just programming actually. It is about ability to look through the code, understand what is the meaning of this code, correlate with the design behavior, ability to debug the issues is the skill set. This is not something you learn in 1 day or 2 days or 1 week or 2 weeks. This is a practice that you develop over months, years together. Okay. You got a feel of what is the role typically expected of a verification engineer role. A physical design engineer don't have anything to do with code. His role is to implement the design in the chip, do the floor planning. I mean, his role will be like given a chip, where to place the block, where to place other block, how to connect them, how to make sure that there are no timing violations. So his work doesn't involve anything to do with code. Okay. So why am I explaining these things? So that you will be able to make a right decision. I mean, if you find this kind of work is interesting, you can go for front end domain, functional verification domain, otherwise back end domain. There is no easy thing, there is no very hard thing. Means if you ask me which one is easy, there is nothing like no easy thing. Which one is very hard? Nothing is very hard. Just have to learn in the right manner. Only thing is, if you want very easy thing, you'll also settle in a very easy thing. I mean, place where there is no growth, no right salary. Simple analogy: security guard is there. His job is nothing, right? That doesn't involve any brain work. He has just to sit for his time and go off. So there is no growth there, right? Point I am trying to tell is, if you want that better salary, better work, you need to put effort and learn the things. I didn't want to compare security guard anything here. All I want to tell is, you want a better life, better work, better salary, you need to put effort and learn the things. There is no alternative for that. There is no easy thing here. There is no easy thing like you join a course, you will get a job. It's not going to happen, because tomorrow I won't sit with you and debug this, right? There is a problem, you will have to debug, you have to learn that skill set yourself. Unless you have that kind of some skill set, companies won't hire you, whatever I do. So in summary, Joining a training institute doesn't guarantee job. Joining training institute provide you the guidance how to approach in the right way, where what to learn. We will teach you some scenarios. Given an issue, how do you debug? Then you have to put and effort and learn that skill set yourself. So you need to identify, for me to be into this job, what skill set is required. I should be okay good with the Verilog, system Verilog, little bit of UVM. I should be good with the debugging skill. I should be good at developing the test bench. That skill set you should develop. Is that clear? Next. So more about what is test bench, what is reference model, how do we debug, we'll understand in the course. I didn't want to teach too many things now. Rather, I just wanted to give you a feel. I hope you got a feel of what is the issue. Okay. I mean, that's the reason we have set up a long course schedule so that we give you exposure to everything in detail. Now let us talk about the training schedule. Mode of training, first of all. Training is offered in full week mode, weekends only mode, sometimes in some cases weekdays, evening batches also. Okay. Full week training is available in online, offline, hybrid model. Hybrid model means partly online, partly offline. Let's say someone is in Hyderabad, for example. They can't come immediately. They can attend for now online. After a few months, they can come to Bangalore and attend offline, so that they can switch. There's no restriction there. Even now, let's say you're in Bangalore, you want to go to home for 2 months, attend from there. That also can be done, as long as you can manage your preparation. It's not like I should be there with you. Are you studying this 1 hour? Next 1 hour, are you studying? That won't work here. You should have that interest to learn yourself. Okay. In all these cases, I mean, that kind of motivation is required to get a job. You should not be thinking that someone will ask me to come sit, do some questions, he will help me. That approach is not going to help you. You should have an attitude where you should start doing things. You should go to the trainer for support. In all these modes of training, you get access to the recorded videos for 2 weeks for every session. You will have access to the videos so that you can revise them. Next is weekends only training. In weekend only training, currently it's offered only online, because mostly the people who go for weekend training, they are working professionals. Many times they want to attend online only. And in case you want to come to institute for offline doubt clarification, you can come. There will be a dedicated mentor who you can come to the institute and get your doubts clarified. Here you have access to all the recorded videos for entire course duration. So understand, access to all the videos for entire course duration, because you are only attending weekend. Those people will be watching the videos during weekdays in the evening, so we give access to entire duration. Next, third thing is weekdays evening batches. It is mostly again working professionals, but it is a minimum requirement is there. At least we need 6 to 7 people to do a batch. If there are only 1 or 2 people, we can't really run a batch for 1 or 2 people. Irrespective of mode of training, every student has a dedicated mentor for doubt clarification. I mean, whenever you have doubt, you can connect with the mentor and get your doubts clarified. I hope you got an idea about what is the mode of training. Now let's talk about a little bit into functional verification thing. So as I said, this RTL design and verification training is same as design and verification training, ASIC verification training, functional verification, everything is same actually. Now talking about functional verification training, it's a 8 months course. Purposefully we have kept it long because I showed you one code. Okay, for you to reach this level, you cannot do in 3-4 months. Okay, this is the industry expectation. If you go to any company, they expect you to come at this level. Need not be expert, but they should know. You should know what is what. I mean, how to approach that, because they don't want to sit with you and explain you, do this now, do this now, do this now. If they explain, they rather they can do it, right, instead of making you do. So expectation is that you should be able to work independently. For that you need time. Why you need time is many people who join the institute lack fundamentals. Okay. The fundamentals in Verilog, fundamentals in digital design also. So it requires time to teach everything from basics, covering all the things. So hence we purposefully keep the course a bit long duration only. But having said that, to get a job, you don't need to wait 8 months. You can start applying for the jobs after 5 months itself. 5 to 6 months onwards itself, you can start applying for jobs. Because the last 2.5 months is focused on the industry level project. Without that also, you can apply for the job. When you get into the job, let's say some training is left, 2 months training is left and you got a job. The company will allow you to complete the training. This 8 months will have 6 days of training per week. Sunday will be off. Roughly 4 to 5 hours per day. General timing is from 9:30 to 1:30. Possibly after lunch also. Sometimes we can have sessions after lunch also. How do we distribute this around 4 to 5 hours? 1.5 to 2 hours of theory session, 3 to 3.5 hours of lab session will be there. Every session recorded video access for 2 weeks. We have our learning platform, e-learning platform, that is inskill.in, where you get, you will be having login access. So you log in through the student login. Once you log in, you will have access to the course. If I take one of the course, let's say System Verilog, for example. Okay. You'll have access to the videos of the live sessions, like the way you see here, all the videos. You'll have access to the course presentations. You'll have access to all the course assignments. Notes and labs also will be available. Okay. It's like one place where you get everything. Okay. You will also get printed copy of the course material. Those who enroll for full course, they get access to the printed copy of the course material. Okay. All the course presentations, assignments and notes are uploaded on this portal. Printed course material provided for all modes of training. For long-term courses, 8 months courses. Let's say someone only enrolls for Verilog, we don't provide. It's for full-time course, we provide. Okay. This training is divided into 3 phases. Phase 1 is for 3 months. Phase 2 is for 3 months. Phase 3 is for 2 to 2.5 months, roughly. So the training will go around 8 months or so. Okay. My point is, you will be ready for job as soon as you are done with this. So hence you don't need to wait for 9 months, 1 year to get a job. You can start applying for job. Yes, full-term course includes DFT also. Means anything around 6 months course is a full-term course. Okay. Phase 1, we teach advanced digital design, Verilog and Verilog projects. Then we also teach GVM text editor. Phase 2, we teach system Verilog, UVM, Linux commands and soft skill training. So placement support starts here. While you are in phase 2, while you are completing phase 2, your placement support will start. Phase 3, we do industry standard hands-on projects like AXI, AHB, APB, Ethernet MAC project, these things. We do Python scripting here. Then SOC flow basics. So these are all things covered in the phase 3. Phase 1 and phase 2 helps in getting job. Basically, interviews will be focused mostly on these things only. They don't go to this extent many times. Phase 3 is what is actually helps in do well in the job. When you go to the job, see, if I was showing you this code to debug this, to figure out the issue, you don't need to be system Verilog UVM expert. You don't need to be expert with system Verilog and UVM. You need to be able to correlate the code. What is this always block is about? What this if condition is doing? What is this if condition is doing? So that skill set you learn only when you do industry level project and you manually debug it. Okay. The problem is even if you become expert in SV UVM, it's not going to help in the job. What helps you in the job is doing some project on par with the industry level. Got it right? Because many times when you go to the job, you don't develop everything from scratch. A lot of things are already developed in the company. You work on those things already. Because of that, other skill set is more important. How do you debug? Okay, those kind of things. Almost all other institute training stops after phase 2. Many companies, many institute you see, their training will stop after phase 2. They may do project, but a small project they will do. And generally the training will be a little bit compressed. Instead of doing it over 6 months, they may do it in 4.5 months, 1 month for project, and 5.5 months like that, they will finish it off. Which the problem with that is it is not sufficient for you to do well in the job. So other institute may do a small project which is not in line with the industry requirements. It won't meet industry requirements. So there the problem will come. What problem will come is, since your preparation is not up to the standard, they again take you to another 3-4 months of training internally. Once you join the company, they'll again take you through another 3-4 months of training, which is a time waste for them. Then it is also a problem for you where they will keep you at a lower salary during that time. So a lot of problems are there. Rather, what we do is we extend the training duration. We teach the things which is all industry relevant. But having said that, at the end, interest should be there in you to learn. Without that, wherever you join, whatever you do, it's not going to help. Just joining institute doesn't guarantee job. You have to join the institute, you have to put effort, learn the subject. That will guarantee the job. Same thing for experienced engineer course. Only thing is in experienced engineer course, it's a 6.5 months course. We cover system Verilog UVM. Entire UVM will be covered, including the main course and advanced course. Otherwise, everything else is same. Verilog won't be there, digital design won't be there. Similar schedule will be there for FPGA also, where in the phase 1 we cover digital design Verilog. Phase 2 we cover some FPGA basics and standard protocol. Phase 3 we do industry multiple projects using FPGA board. So I won't go into DFT and other things because there will be another DFT specific demo session where the trainer will give you the entire DFT flow. So I'll skip this part. So I hope you have understood the schedule and how the training is divided into 3 different phases and why all those phases are important actually. Okay. All those are important because job is not about just clearing the interview, should be able to perform well in the interview, right? Otherwise what will happen? You will be having difficulty every day. If you can't do well every day, there will be a problem for you. So that we are trying to make sure that you don't go through that phase by providing that level of training. Many times why institutes don't extend 8-9 months other places, they lack resources means trainers you need to run such a long course, you need training rooms and facilities. So we luckily have the things. We have the multiple training rooms, almost 10 training rooms where we can run 10 parallel batches, and we have the sufficient number of trainers to do the courses. For us also, it's difficult to run long batches. Actually, 8 months is very difficult to run. But then, student who passes out of the institute should go with the right skill set. Then only we are doing our job as an institute. If I just do for sake of doing and send you out, it won't be good as an institute. Now, how to choose the right course? With so many domains, right? I said front end domain, back end domain, FPGA. So how to choose the right course? You can look at your expertise as a three possibilities. One is you are very good with programming. You have done programming, you are very good with programming, you have done Verilog, you are comfortable with Verilog. Then you by default go for functional verification. It has good job opportunities. FPGA system design. What is second one? You don't have very great expertise, but you are okay with programming, medium level of expertise. Uh, you can think about FPGA system design also. It needs expertise of working with the tools also. Third is it also has good opportunities. If you don't need any programming kind of job, then you can think of third option, that is backend domain. There you can choose physical design, DFT, STA, custom layout. Okay. It requires no programming expertise, tool and technology oriented job. You need to be expert with the softwares, how to use software, how to understanding of the technology basics, those kind of things. But one of them you should have. One of them you should develop that interest. We offer a course flexibility in the institute where you join any course, you can switch to any other course up to 2 months without paying any additional fee. Let's say you join front end domain, you can switch to back end domain without paying any additional fee. No need to repeat entire 2 months in new course. Let's say when you rejoin, you don't have to repeat entire 2 months. 1 month is common. For every domain, initial 1 month is common. You miss only 1 month. So what you do is you join into the next batch. So that way you are in continuity. Understood, right? Initial 1 month is common for all the courses. You join into the next batch of training where 1 month topics are covered. Next, preparing for job. What is a difficult part of training at VLSIGuru Institute is that things move quickly. Not only here, everywhere you will probably notice the same thing. Okay. What is meant by things move quickly is generally during your BTech, what happens is you do each subject for 4-5 months. Let's say digital design, starting from day 1 till end of semester, you will have some same subject. You will be reading, you will be in touch with the subject. Signals and systems. You'll start from day 1, goes till end of semester. Same thing, right, for every topic. There you are in continuous touch with the subject. Here, how the course is divided is, we do one topic at a time. Let's say we do digital design, only digital design during that period, nothing else. Let's say we move to Verilog, only Verilog. So what is the problem you see there? What has been done 6 months back, you forget. You need to keep revising continuously. You need to keep revising the topics continuously. That is the only reason why people don't get job. What is the reason? What has been done in 6 months back, let's say 6 months back, someone did digital design. Now if I ask him what is XOR gate, how to implement multiplexer using XOR gate, he doesn't know. Then he can't get a job. You cannot say that 6 months back I learned, so I forgot. Can you say that? Right? So that is the reason why people don't get job. Means it's about planning properly in such a way that whatever has been done 6 months back or 3 months back or 5 months back, how do you make a notes and keep revising, keep doing some questions so that you are continuously in touch with the subject. So getting a job is about little bit of planning. You got it right. Reason is, once you complete your training, you don't get 100 opportunities. You get some opportunities, let's say 20, 30 opportunities. Okay, many times what happens is, by the time they realize that their mistake, it's already, many interviews are already done, they lose those opportunities. So I want to tell you that you have to be consistent. Means, in terms, you have to keep revising. You don't need to spend full day to revise digital design. Let's say digital design is over in January, sit once in a week or 2-3 times in a week, you revise some questions. That way you are in touch with the subject. That is the very important part. Second thing is, you be in sync with the trainer. And coming back to this, what is difficult part of training here is, lot of things are covered in each and every topic. Digital design, what you learn in your BTech, what we teach in our courses, very different. We teach lot of things. What you learn in your BTech Verilog, for example, you have done Verilog, and what we teach here is very different, because there you don't have to join a job. When you do in your BTech, you are not looking to join a job. Your idea is to get good percentage or good grade points, right? Here, grade point or percentage doesn't matter. My company which comes don't ask what is the grade point of this person in the course. We'll only ask how he is doing in the interview, how good he is with the subject. So we have to teach to that expectation. So we go depth on it. So roughly I can compare this 8 months of training will be like a 2 years of your BTech. That much content gets covered. So sorry, what I was trying to tell here is that a lot of things happen in a shorter duration. You need to be focused during this time. Okay, to get a job, a 6 hours of decent effort, 6 hours of effort per day, including the session time, is sufficient to get a job. If you spend every day 6 to 7 hours, including the time you spend in the class, you will get a job. Okay. Many times people don't get job because they don't do it consistently. I mean, when I say 6 hours, including Saturday and Sunday. Saturday you revise what all things happened in Monday to Friday. Sunday again you revise. Sunday you write your own questions. You do questions. That if you do in a basic planned manner, you get a job, and you can even get into very good jobs also. We track the students' performance. We divide the students into good performing students, average performing students, and poor performing students. Idea is not to discourage anyone. Idea is to provide that additional support. If someone is not doing good, we need to provide that additional support, right? Because uh, once this training is done, there is nowhere else they will join course. Let's say after school you have high school. After high school there is a college. After college then there is some MTech, whatever. After training institute there is nothing else. You have to get into job only. So we understand that, we try to fill that gaps, whatever gaps you have. Sometimes people don't have good communication skills, because to get a job you need decent skills, how to communicate, how to talk. That also we take care, that also we provide training, soft skill training. Let's say you are not good with aptitude, we give you the required inputs to improvise an aptitude. So all that. So this performance tracking is done based on how you do in the assignments, uh, your attendance during the sessions, how you perform in evaluation test, how you do in presentation. I mean, we'll give you a topic which on which you have to do a presentation. So student is given a topic, asked to do a presentation, one presentation every month, and mock interviews. So based on all these things, we categorize the person into good, average, and poor. So sometimes if the person is not able to catch up, we encourage him to join in the next batch, so that he gets that additional time to learn the things. Okay, there won't be any charges for that additionally. For every student, there will be a dedicated WhatsApp group for every student, where you post your queries, and our trainer will address all those queries. Okay, so in that group, trainer will be there, admin will be there, student will be there. If you have some technical queries, you connect with the trainer. If you have some non-technical queries, admin will help. So what is the final goal of 8 months of training? If you, I mean, at the end of 8 months, what is the expectation? Is that very simple expectation? Student should be able to work in the job independently. Let's say you join some project in Intel, Qualcomm tomorrow. Are you able to, your manager will give you some work. Are you able to do that work independently without taking any kind of major support from the team members? That is the expectation. It's not about learning SV. It's not about learning UVM. It's all about, have you got to that level where given a problem, do you understand the problem? Do you understand how to approach the problem, solving the problem? What skill set is required? That approach you have to develop. Once you develop that approach, system Verilog and UVM, they are not going to be very significant. Okay, you can get into any job and work. Okay. So our coursework, attendance, assignments, evaluation test, presentation, they are meant for that direction to give you that kind of preparation. Okay. So it's a collective effort. Means just the institute cannot do everything for you. Okay, and just the student alone cannot do without any guidance. It's a collective effort where we give you the right direction and you utilize that. Okay. So this is about it. What are the course prerequisites? Should be very good with quantitative aptitude. The point is, aptitude is about logical analysis, right? Given a problem, how to understand the basic problem, how to understand it as different variables, how to solve that equation. That is the logical analysis we are talking about. Someone who wants to get into any kind of job, not just VLSI, needs quite good aptitude skill. Okay, basically it's about ability to understand the problem and conceptualize what to do. Okay, and should be able to do logical analysis. So what you should do is, before taking this course, you should take a sample test online. If you score less than 30% or 40%, you should not join any course. You should first spend 1 month time preparing quantitative aptitude, come to a level where at least you score 50% like that, then only join a training. Okay. Take this input seriously. I mean, you can randomly go and just say quantitative aptitude online test. You should be able to score minimum 30 to 40%. Anything less than 30% means you are poor, you are not good. So you won't be able to understand the training itself. If your percentage is less than 30% in quantitative aptitude kind of exams, whatever I teach, you won't be able to understand that level. You won't be able to correlate the things because your mind is not ready for that. So that you please should do that. Only then you can join training once you are comfortable with aptitude. You may say, what is the relation with VLSI? It's not, VLSI and aptitude are different because they are, but aptitude defines your ability to think logically, correlate the things. That is a common skill set required for everywhere. Yeah. Why join VLSI? Our course is institute is. Many times people join other institutes. They come to us for advanced courses, like projects. They come to us, protocols. They come to us. So there they pay already. Here also they pay again. Rather, if you join here, you do everything as a package itself already. The project and the protocols are already part of that course, and fee is also relatively less compared to other institute. Overall fee itself. Okay. So in this case, the person who has sent me a mail some long back, okay, he has joined some other institute. Now he wants AMBA protocol training course. He can't pay because he has already spent a lot of money there. Okay. Of course, what we have done to him is a different thing. All I'm telling is our course is a full-fledged course which covers everything. You don't have anything left. Like you learn Linux operating system, you learn scripting also, you learn SOC concepts also in a single package. Okay. And it comes with the placement support as well. And that support will be till the time you get a job. Though I will not guarantee when you get a job. Let's say today you're joined in January. I won't tell that by July I'll give you a job. We will continue to support you till the time you get a job. We create a WhatsApp group through which you keep getting the requirements. You apply for the jobs, and as in we then connect you with the companies. And through that you get this. So this is a brief about the front end domain training. Any questions so far? Yeah, I was telling you that, okay, what is the skill set required? We teach everything from basics. My point is, if you are good with Verilog, that's a added advantage. Even if you don't know Verilog, even if you don't know digital design, no problem. Only thing, two things are required: aptitude, attitude. Right aptitude, you should have basic quantitative aptitude. You should have the right attitude to learn things. If you don't learn, if you don't understand things, you should be open to ask the question to the trainer. You should not be shy what other people will think if I ask question. If you don't know the things, you should be able to spend that additional time and prepare. Let's say today I covered some topic, you didn't understood, you should have that willingness to work in the late in the evening, let's say 11 o'clock, 12 o'clock, and somehow I have to finish that. That attitude should be there towards learning. Then you don't need any prerequisites. Even if you don't know digital design, even if you don't know Verilog system, Verilog, no problem, everything will be covered from basics. But right aptitude, right attitude is what is required. Choosing right domain, as I told you, right, you start with any training with the front end, you don't like it for like it, you can switch to back end domain or vice versa. Why VLSI? VLSI job you should do because there will be opportunities in VLSI in foreseeable future. It's not going to end anytime because electronics are part of life right now. I mean, we everywhere you go there is electronics. It was not the case 40 years back. 40 years back there was a very little electronics. Mobile TV, television was a very rare thing in very few houses. There was no mobile phone, there was no speaker, nothing, right? Now electronics is part of the life. So as long as electronics are there, VLSI will be there. Okay. But number of opportunities may increase, decrease, that we cannot say. Okay, like in any other domain. So here there are a lot of companies who work into VLSI. There is a, you don't need to reskill every time. What is mean by that is there is no need of uh, reskilling. It means whatever I learned in 2005 when I started my career, same thing is applicable now also. A lot of things I use today also. I didn't really reskill too much. I only thing I learned is learn new protocols. Now I know around 15 protocols as a at expert level. So that is where I differ from other people. I mean, I can teach PCIe comfortably, DDR comfortably, USB comfortably. So that is my skill set. That additionally I gained over the time. But what is the basic skill I learned? System Verilog UVM in 2005 to 2007 timeframe. I even use today. And industry VLSI is a well-paid job generally. Now we are done with the demo. If you have any questions, we can go through. I didn't go much into the technicals of functional verification because unnecessarily it may extend and you may not understand everything. But I hope you got a feel of what is functional verification, right? What a functional verification engineer does. Now you can please post your questions in the chat window. I have attend e-learning course. Where should I ask my doubts if I have any? Generally, what happens for e-learning course, every weekend there are dedicated sessions. Second is, even You don't need to wait till Saturday and Sunday. Same day you can post the question in the group. Our trainer will support. Like what I will tell you is there will be a group for everyone. So the student will post the request here. Okay. Let's say posted some time back. Our trainer, our admin will take little time and address this query. Let's say here, the admin has posted some, the student has posted some query. Our trainer will reply back. Okay. So it could be the trainer or admin based on whether the query is technical query or non-technical query. So this WhatsApp group will help you get the quick resolution to the problem. So once you enroll, you have this ID. Okay, like let's say 9711 is your ID for this student. So every student has that unique ID. Through that only we track you, like what is your performance, okay, what support you require, everything. It can be a small course or big course. For example, she enrolled only for ASIC course, which is only 1 month course only. She will also have an ID. Even person who enrolls for full course, they will also have a ID. Okay. Through that we track it. That is where you get all the support. Like see, it says all support requests should be posted here. We assign a trainer, then we assign a admin to support it. Any other questions? Yeah. So in summary, you can post your questions in the group. Our trainer will respond, or if required, trainer will have a dedicated call with you to support. In other case, you can even have the things clarified during the weekends also. For DFT course, I think the Monica was looking for DFT. There will be dedicated lab sessions every weekend. Do we get certificate after completion of course? Yes, you do get. But what is more important is the skill set you gain is more important than a certificate. So once, please ask your question. Yes, I will tell you. Live lab session. I'll answer. Uh, yes, let me answer your question first. Yes, it is preferable. There is a lab room, the one where you're sitting. Here itself you can practice. But sometimes what happens, the lab sessions can happen in a different training room also. Okay. So it is very much suggested to have your laptop because you can't be preparing in the institute throughout the day, right? You could be going to your home PG and there you could be preparing. Because of that, having your laptop will make it easy for you to prepare. Laptop configuration would be, see, one is go for SSD, right? Okay, never go with a HDD one. Okay. On top of that, let's say i3 or i5 will do. Plus, what is it? 8 GB RAM. If you can do that, this is the best configuration. At minimum end, this is the best configuration. Let me start. Sorry. AI can affect this. We'll discuss. If we have a career gap, does it affect in VLSI domain in package also? It depends upon how much career gap you have. Let's say someone is 2005 pass out, too late right now to do anything. So it depends. If someone is 2020 pass out, it's actually advantage. Better than 2024 pass out. 2020 pass out is better than 2024 pass out. Why is it in this case? Companies, you undergo same training as other one. Companies will hire this person a little more preference because they show that 4 years gap. Out of that 4 years, they show 2-3 years some internal experience, company experience. So they project you as an experienced person to the client project and their project. So their small gap will be advantage. Very large gap, then it's difficult. So in summary, career gap doesn't mean you won't get a job. You can get a job everywhere. See, for all the things, even if it is 2005 pass out, 2010, 2020, or 2024 pass out. One common thing that is required is a very good preparation, expertise with the subject. Once you have expertise, some or other thing will happen. Even if you are 2010 pass out, you can still get into the industry. Timings of online courses. Typically the same timings I told you, right? If you are looking for full week, basically offline and online classes are done parallel. Whatever offline I am doing, same training is being done to the online students. So there is no difference in the schedule. 6 days per week, 4 to 5 hours per day. Preferably in the morning, first half. Sometimes session can extend in the later half also. This is the schedule. If you are looking only weekend, around 4 hours on Saturday, 4 hours on Sunday. First, we give you access to the entire course videos. Any questions? What is the difference between post-silicon validation and pre-silicon validation job role? One is post-silicon validation, one is pre-silicon validation. Let's understand. Pre means what? Before. Post means after. Pre-silicon means what? Before silicon was manufactured. So before silicon was manufactured, what is the format it was present in? Code. So verifying RPL code. That is Verilog RPL code. Finding any design issues. Called as pre-silicon validation. It is also called as same as functional verification. Post silicon validation means verifying the chip that is manufactured. Already you have chip is manufactured, but you validate it. You don't call it as verify, you call it as validation. Whether it's working as per expectation is called as post silicon validation. Once it is manufactured. It needs a different tools. See here, since you use RPL code, you need simulator like VCS simulator, model sim simulator. You mostly work at the coding level. Here, there is no code involved here. You are working with the physical silicon, physical chip. So you need a different set of tools, testers, analyzers. You need a different kind of tools. But in both the cases, you need some understanding of the design. Is weekday weekend training completes in 8 months? Weekday weekend batch may get less hours. How it will be compensated? That is where I said weekend batch you get access to all the videos. So weekend batch we cannot do everything in sessions only. We give you access to the videos. Over the weekends you have the revision sessions. I mean revision support sessions, the top assignment solving. We cannot do everything over weekends at times because it's not practical, right? Functional verification course include design also. I mean design and verification course. Yes, even though we call functional verification, it includes design also. We teach Verilog code, Verilog designing, Verilog test bench development. Some recent placements are like, see, we had placements happening in physical design, even in design verification, even in DFT. So some of the placements into TV are into some company called Blueberry Semiconductors has hired 5 people. And other than that, we had placements in uh, companies like Chip on Time. And I need to look through the list 1 second. I can tell you. Some placements happened in Smart Sock company. Okay, 2 people got. Recently, Siemens has come for requirements to us. That interview is in progress. Okay, Micron interviews are happening. Then Scale Edge Technology, Bhubaneswar-based company. Some 4 people got selected. And other than that, in semi interviews are in progress. I said Blueberry Semiconductors, around 5 or 6 people got selected. These are the few things that happened in last 1 month. Similarly, we had placements in PD. I mean, right now, let's not get into it because it's let's focus on DV domain. Okay. Uh, any questions so far? DFT. DFT for last 1 2 months, not much placements. I think DFT only one placement I see is they hired one. Yeah, Qualcomm one placement happened. One person by name Gauri got selected. Yeah, we did have, sorry, Qualcomm. Then we had one company called as Def Semiconductors. Okay. One, let me just check. Siemens hired one person. And Qualcomm hired one person. There's a company called as Sondrel Technologies, SIGPT. There are few companies. Juntron, one company, has hired 3 people. So there are hiring did happen in DFT. Is demo on FPGA system design available? Yes, it is available. Please connect with admin. So please message to our admin. We will inform you the schedule. AI impact on VLSI jobs. It's a bit early to say this, but there could be impact. There could be 10 to 15% jobs impacted. because way it is happening in other domains, even in VLSI, they will try to automate some of the things. That's why there could be impact of 10 to 15%. How these courses help are good enough for career changes? These courses are good because you do all the skill set you learn. Once you learn to go through this course, your skill set is on par with a 2 to 3 years experience in this. So that would be sufficient for you to change the career lines. Because when you go to a job, they want people to have able to work independently, right? So that comes with that level of expertise. Will you provide 2 lakhs as 24/7? Yes. Uh, have they hired in DFT physical design also? Yes, hirings happen in DFT physical design also. Currently, yes, I mean, we have seen more hiring in functional verification compared to other domains. Any other question? I would suggest means taking the course or what is no, I didn't get your question.
Once you have done the aptitude before taking the classes.
I would suggest you to take some aptitude test yourself. If you are comfortable with the basic aptitude, then you start. In summary, I mean, see, it's more than opportunities. Uh, whoever has been good, I mean, whoever has done the course properly, have done the courses, and they have been getting job. It could be DFT, it could be physical design. I mean, I haven't personally kept track of each and every hiring in DFT because I'm into verification. I generally kept track of how the students from my batches have been getting placed. So maybe our placement coordinator can give more details on this. There have been placements. It's about having the right preparation. People do get it.
DFT will be come against the front end or back end both.
DFT will be done in both front end domain as well as in back end domain. In, see here only reason why we use the term front end and back end is more like front end means domain where you need programming kind of expertise. Back end doesn't need any programming expertise. So if I have to go by that definition, DFT will be back end because in DFT you don't need any programming expertise. Any other questions? Fine. If you don't have any questions, we'll end the session here. Okay. So I will be staying here. Those who are attending online, if you have any questions, I mean, those in offline, if you have any questions, you can stay back. Uh, those attending online, do you have any questions? Okay, in case you want to enroll for the course is starting from Monday onwards. Basic schedule will be Monday and Tuesday for 2 3 days. Some basic topics will happen. Linux and GWIM kind of topics will happen. After that, around Wednesday or Thursday, the main content will start digital design because see what happens 1 or 2 days people will be joining starting digital design. What will happen is they lose the 2 3 days of session, so they'll be out of sync. So if those who want to enroll, the course will start from Monday. So how to enroll? You can pay 5,000 towards enrollment fee, and this is the link where you can make the fee payment. Okay. Thank you. We'll end the session here. Which course is starting Monday? Actually, every course will start on Monday itself. Uh, which course is start Monday itself? See, as I said, for all the courses, 1 month is common, right? Initial 1 month where we do digital design, GVim, Linux, basic concepts. These all common. So hence, for all of them, Monday it is start. I'm joining to a DFT course. Is it good to get a job? Yes, even if you join DFT course, you can get a job. You learn the subject properly. Should we pay entire fee in single payment? No, I think there are installment options. You can pay in multiple installments. Fine. Let's end the session. Thank you, everyone.